Pipeline integrity, preparedness for incident management, ensuring safety through proactive risk and emergency planning. Introduction to pipeline integrity, agenda overview. Pipeline integrity refers to the ability of a pipeline system to operate safely and reliably throughout its lifecycle. It encompasses design, construction, operation, and maintenance practices aimed at preventing failures that could lead to environmental damage, safety hazards, and financial losses. Maintaining integrity is critical because pipelines transport hazardous materials over long distances, often through sensitive areas. A failure can result in catastrophic incidents, including explosions, leaks, and contamination. Preparedness for incident management ensures that organizations can respond effectively to emergencies, minimizing harm and restoring operations quickly. This introduction sets the stage for understanding why proactive measures, risk assessments, and emergency planning are essential components of pipeline integrity management. The presentation will cover key aspects of pipeline integrity and incident preparedness. We begin with an overview of common pipeline incidents and their causes, followed by a detailed look at incident management frameworks. Next, we will explore risk assessment methodologies, emergency response planning, and communication protocols. The session will also highlight the Incident Command System or ICS, technology tools for monitoring, and the importance of training and drills. A real-world case study will illustrate lessons learned, and we will conclude with regulatory compliance requirements and strategies for continuous improvement. This structured approach ensures a comprehensive understanding of how to maintain pipeline integrity and respond effectively to incidents. Common pipeline incidents, risk assessment and hazard identification. Pipeline incidents can range from minor leaks to catastrophic ruptures. Common causes include corrosion, material defects, operational errors, and external interference such as excavation damage. Natural hazards like earthquakes and floods also pose risks. Understanding these incident types is crucial for developing targeted prevention and response strategies. Corrosion, for example, can be mitigated through coatings and cathodic protection, while third-party damage requires robust monitoring and public awareness campaigns. By categorizing incidents and analyzing root causes, operators can prioritize resources and implement effective safeguards. Risk assessment is a systematic process for identifying hazards, evaluating their likelihood and consequences, and implementing controls. Techniques include qualitative methods like HAZOP, hazard and operability study, and quantitative approaches such as probabilistic risk analysis. Key factors considered are pipeline age, material properties, operating conditions, and environmental sensitivity. Hazard identification involves mapping potential failure points and assessing exposure to threats. A risk matrix is often used to prioritize risks based on severity and probability, guiding decision-making for maintenance and emergency preparedness. Emergency response planning, communication protocols. Emergency response planning ensures that organizations can act swiftly and effectively during a pipeline incident. Plans typically include procedures for detection, containment, evacuation, and remediation. Key components involve resource allocation, personnel roles, and coordination with external agencies. Drills and simulations validate the plan's effectiveness and identify gaps. A well-structured emergency plan reduces confusion, accelerates response times, and minimizes environmental and financial impacts. Integration with local authorities and adherence to regulatory requirements are essential for comprehensive preparedness. Effective communication during an incident is critical for safety and operational continuity. Protocols define how information flows between internal teams, emergency responders, regulators, and the public. Clear, timely communication prevents misinformation and ensures coordinated action. Tools such as emergency hotlines, mass notification systems, and digital dashboards facilitate rapid information sharing. Predefined templates for press releases and stakeholder updates help maintain transparency and trust. Training personnel on communication procedures is as important as technical response capabilities. Incident Command System or ICS, technology and monitoring tools, training and drills. The Incident Command System or ICS provides a standardized approach to managing emergencies. It establishes clear roles and responsibilities, ensuring efficient resource deployment and decision-making. ICS structures typically include an incident commander, operations, planning, logistics, and finance sections. This hierarchy enables scalability for incidents of varying complexity. Training staff in ICS principles enhances coordination and compliance with regulatory frameworks. ICS integration with company protocols ensures seamless collaboration with external agencies during major incidents. Advanced technologies play a vital role in pipeline integrity and incident preparedness. SCADA systems provide real-time monitoring of pressure, flow, and temperature, enabling early detection of anomalies. Leak detection technologies, including acoustic sensors and fiber optic cables, enhance situational awareness. Drones and satellite imagery support rapid assessment of remote areas. Predictive analytics and AI-driven models help forecast potential failures, allowing proactive maintenance. Investing in these tools improves reliability and reduces response times during emergencies. Regular training and drills are essential for building competency in incident management. Exercises simulate real-world scenarios, testing the effectiveness of emergency plans and communication protocols. Training programs should cover technical skills, decision-making under pressure, and coordination with external responders. Post-drill evaluations identify strengths and areas for improvement, fostering a culture of continuous learning. Certification programs and compliance audits further ensure that personnel are prepared to handle complex emergencies. Real-world incident case study, regulatory compliance and standards. A notable pipeline incident involved a rupture caused by corrosion in a remote area, leading to significant environmental damage. The response highlighted the importance of early detection and rapid mobilization of resources. Lessons learned included the need for improved monitoring systems, better coordination with local authorities, and enhanced training for field personnel. This case underscores the value of preparedness and continuous improvement in incident management strategies. Compliance with regulatory standards is fundamental to pipeline integrity and incident preparedness. Guidelines from organizations such as API, American Petroleum Institute, and PHMSA, Pipeline and Hazardous Materials Safety Administration, set benchmarks for design, operation, and emergency response. Adhering to these standards ensures legal compliance, reduces liability, and enhances public trust. Regular audits, documentation, and reporting are critical components of a robust compliance program. Conclusion and recommendations. Pipeline integrity and incident preparedness are interconnected priorities that safeguard lives, assets, and the environment. Organizations must adopt a proactive approach, integrating risk assessments, emergency planning, technology, and training into their operations. Continuous improvement through lessons learned and compliance with regulatory standards ensures resilience against evolving threats. By fostering a culture of safety and preparedness, companies can minimize incident impacts and maintain operational continuity.